Hello students, welcome back to this lecture series of M.Sc. Part 1 Mathematical Methods in Physics. In the last class we discussed about the Hermite polynomial functions. In this lecture we are going to discuss some recurrence formula for the Hermite equations. Okay, so first recurrence relation, that is 2n h n minus 1 is a function of x is equal to h prime n x, and the second one, that is 2x hn is a function of x is equal to 2n into hn minus 1 plus hn plus 1, and the third one, that is h prime n is equal to 2x hn minus hn minus 1. Okay, so here we try to solve this first recursion formula. It's 2n hn minus 1, the function of x is equal to h prime in x. Okay, so we know the generating functions of these Hermite differential equations, that is e raised to 2xt minus t square is equal to summation over n is equal to 0 to infinity h n t power n divided by n factorial. Okay, this is a Hermite generating functions, and this h n is a polynomial, Hermite polynomials. Okay, so if I differentiate this with respect to the x, so it is 2t e raised to 2xt minus t square is equal to summations over n is equal to 0 to infinity h prime n t power n divided by n factorials. Okay, now this 2 e raised to 2xt minus t square we can replace with this thing, so it is 2t summation over n is equal to 0 to infinity h n t power n divided by n factorial is equal to summation over n is equal to 0 to infinity h prime n t power n divided by n factorials. Okay, so this t we can write like this: 2hn t power n plus 1 divided by n factorials. Okay, this plus 1 for this thing is equal to h prime n t power n divided by n factorials. Okay, now we want a 2n, so 2, okay, we want 2n h n minus 1 is equal to h prime. Okay, so here this 1 by n factorial we can write like this: 2n divided by h n t power n plus 1. For this n plus 1 we can replace, we want the t power n, so for that h n we can replace minus 1, so here the t power n and divided by n minus 1 factorial is equal to h prime n t power n divided by n factorial. Okay, just replace this n with the n minus 1. Okay, so 1 minus 1 divided by n minus 1 factorial we can write n by n factorials. Okay, so this 2n h n minus 1 divided by n factorials, n by n factorial for this 1 by n factorials, 1 by n minus 1 factorial. Okay, into t power n is equal to h prime n t power n divided by n factorials. Okay, now equate the coefficients of this t power n by n factorials. Okay, so you can write like this. Okay, so equate the coefficients of the t power n divided by n factorial, so we get like, okay, from this So it is 2n hn minus 1 is equal to h prime n. Okay, see this hn is a function of x. 2n hn minus 1 is a function of x is equal to h prime n, a function of x. Okay, so this is the first recursion relation from the we can find from the using the generating functions. Okay, now second one, that is 2x hn x is equal to 2n hn minus 1 is a function of x plus hn plus 1 is a function of x. Okay, here also the we can use the relation of generating functions with the polynomials, Hermite polynomials, that is e raised to 2xt minus t square is equal to summation over n is equal to 0 to infinity hn t power n divided by n factorials. Okay, okay, so here differentiating these relations with respect to the t now, so it is 2 if I differentiate, so it is x minus t e raised to 2xt minus t square. Okay, with respect to the t, so it is summation n is equal to 0 to infinity h n into t power n minus 1 divided by n factorials. Okay, so this is after the differentiating with respect to the t. Okay, now 2x e raised to 2xt minus t square minus 2t e raised to 2xt minus t square is equal to summation over n is equal to 0 to infinity hn n into t power n minus 1 divided by n factorials. Okay, so this n by n factorials we can write 1 by n minus 1 factorial. Okay, but here if we write 1 by n minus 1 factorial, then this summation from 1 to infinity, because if I put the n is equal to 0, so these things will vanish. Okay, so we can also write like this, n minus 1 factorials. Okay, so here summation is 1. Okay, or e raised to 2xt minus t square we can replace with this thing, so it is 2x summation n is equal to 0 to infinity hn t power n divided by n factorials minus 2t summations n is equal to 0 to infinity hn e raised to t power hn t power n divided by n factorials is equal to this thing. Okay, okay, so it is 2x, you can write summations n is equal to 0 to infinity hn t power n divided by n factorial minus this t, you can write t plus t power n plus 1. Okay, so it is 2 summation n is equal to 0 to infinity hn t power n plus 1 divided by n factorial is equal to this thing. Okay, so it is summations okay. Now we want the t power coefficient here, t power n by n factorial. Okay, so here if we want the t power n by n factorial, so we can put the n is equal to n minus 1. Okay, so if I put the n is equal to n minus 1, so this minus 1 and plus 1 will cancel out, and here is the n minus 1 factorials. Okay, and here we can put the n plus 1. Okay, so we get the 2x hn t power n by n factorial minus 2 hn t power n by n minus 1 factorials is equal to hn minus 1, here is also n plus 1 minus 2 n minus 1, so it is t power n divided by n minus 1 factorials n plus 1 t power n divided by so 2x is n. So this 1 by n minus 1 factorial we can write 2x is n t power n by n factorial minus 2h n minus 1 n into t power n divided by n factorial is equal to h n plus 1 t power n divided by n. So just equate the coefficients of the t power n by n factorial. T power n by n factorial is t power n by n. So from this we can write from this we can write 2x is n, which is function of x, is equal to, or this one, that is 2n plus hn plus 1. So this is second regression formula for the Hermite differential equations. Now, in these equations, if I put the first regression relations, that is from the first regression relation, we know 2n h n minus 1 is function of x is equal to h prime. Okay. So 2n h n minus 1, this we replace with the h prime nx. Okay. So you can find this third regression formula. So it is like this. If I put 2x is n is equal to h prime x plus n plus. So this is third regression relations, okay, from the by using the first and second regression relations. So this is about the regression formula for the regression formula for the Hermite differential equations. Okay. So let's stop here.